Let's continue talking about effective ways of testing our model. We're going now to move into k-fold cross-validation. So we know that r squared tells us what portion of the error that's sort of inherent in our data does our model account for or explain away. And now we want this to be higher. We've also talked about mean square error as a way of assessing our model's performance, and this tells us in general how much are our predictions off. And of course, we want this to be lower. And we can use either of these for testing, but we run into a little bit of an issue. First of all, the data that we use to test cannot be the data that we used to train our model. Now, this should make intuitive sense. You can even use an analogy. A teacher, let's say she gives her students practice problems to help learn the concepts. She can't then put those exact same practice problems on the test, because of course the students could just have memorized those practice problems. The test has to be new questions, or else we don't really understand how much the students have really learned. And this is the same with testing. The data we use to train cannot be the same that we use to test. At the same time, though, we want to maximize the amount of data we have to train and the amount of data we have to test. Ideally, we would use all the data to test and all the data to train, but of course we can't. The data we use to train can't be the same as the data we use to test. But there's a sneaky way to avoid this, and it starts by taking all your data. We'll represent our data with these white circles here. Each is a data point, and we split it into 4 sections, and we can split into how many sections we want. In this case, I have 8 data points, and I'm going to split it into 4 sections. I say my k value is 4. The k value is how many sections you're splitting your data into. Now I'm going to make, in this case, a quarter of my data for testing. So the 2 red dots in this case are going to represent the data points that are used for testing. And the rest, the other 3/4 of my data, is going to be used for training. So all the blue are going to be used for training, and my 2 red ones are going to be used for testing. So I'm going to use my 2 red data points for testing, and in this case I'll calculate r squared. You could have calculated mean square error as well, but I'll do r squared, and I get 0.91, let's say. But then what I'm going to do is I'm going to do it all over again. I'm going to retrain my model and do the testing again, but I'm going to just shift over the data points I use for testing. So I'm going to use these 2 data points for testing, and the rest are going to be used for training. So I'm going to train my model over again on these new data points, and then test it on those 2 red data points, which are now these ones. And again, I'm going to get what my r squared is, and it's 0.89 in this case. And then again, I'm going to shift over the data points I use for testing, and then use the rest for training again, retrain the model, retest it, and this time I get an r squared of 0.92. Now there's 2 data points that have yet to be used for testing. So then I'm going to shift over and use those 2 for testing and the rest for training, and get my r squared value. So you can see, after doing a bunch of iterations of training and testing, I've went through and used all my data for training at some point, and I've used all my data for testing at some point. And the last step now is to calculate the average. So I take the r squared values from my 4 rounds of training and testing and find the average. So in this case, since my k value is 4, I divide it by 4. And this should get me a fairly good idea of how my model performed. And then once I've done this, my final version of my model will just use all the data. So the final model can then be trained off all the data, and then it can be sent out there and used in the real world.